All right, everybody, welcome back. Today we are looking at graphing quadratics. I'm going to put that first. Graphing quadratics. Now, the beautiful thing about this is that we've already mentioned the quadratics. When we graph a quadratic, guys, the graph of a quadratic is referred to as a, do you guys remember? A parabola. So we talked about them with the transformation. So when you look at the graph of a parabola, either the graph is going to open up or it's going to open down. Now, what determines whether the graph opens up or down, guys, is going to be the leading coefficient. So if the leading coefficient is positive, as in it's greater than 0, the graph will open up. However, if the leading coefficient is less than 0 or it's a negative value, the graph will open down. Yeah, that's easy. So look at your A value. If it's positive, it opens up. If it's negative, it opens down. Now, guys, the most important point on the graph of a quadratic is the turning point. The turning point is referred to as the vertex, okay? The vertex is the lowest point on the graph of a quadratic. The lowest point on the graph, the turning point on the graph of a quadratic is called a vertex. So if the graph is opening up, the vertex would represent the lowest point on the graph, which we refer to as a minimum value. I like to abbreviate it with min value. Now, if the vertex if the parabola is opening down, the vertex would represent the highest point on the graph of the parabola, which we refer to as the maximum value. By the way, guys, when we notate the vertex, we notate it as the coordinate point h comma k. There's a reason why we use h comma k, but for now, I'm not going to explain it to you. I'm just going to go ahead and use h comma k, and I'll explain it to you later on, okay? So once again, the most important point on the graph of a parabola is the vertex. That's the turning point. That's the most critical point on the graph of a parabola, guys. So if the parabola is opening up, you will find the minimum value, the lowest point on the graph at the vertex. If the parabola is opening downwards, you will find a maximum value at the vertex because that is the highest point on the graph. All right. Now, additionally, guys, okay, this next part is very important too. These graphs are symmetrical, guys. They're symmetrical. Symmetry, they have a line of symmetry. Here, let me write this down for you. They have a line or axis of symmetry. Now, the line of symmetry or the axis of symmetry goes straight through the middle of the graph, guys. Straight through the middle of the graph. So what it does is it allows the graph to reflect, one side of the graph to reflect across the line of symmetry so that it looks exactly like the other side of the graph. So symmetry has to do with balance. What you see on the left is what you see on the right, and vice versa. What you see on the right is what you see on the left. Symmetry. We talked about symmetry before, by the way. And so, guys, by the way, just a little side note, beautiful people have symmetrical faces. So if you were to draw a line straight through the middle of a face, of somebody's face, what you see on the left is what you see on the right, and what you see on the right is what you see on the left, okay? So symmetry has to do with balance. So the line of symmetry goes straight through the middle of the graph, intersects the graph at the vertex, guys. Now, hopefully you guys can remember this one. This is a little bit further ahead, but I'm going to tell you this. It's an equation, guys. The line of symmetry is an equation because it's a vertical line. It's going to intersect the x-axis. So the equation of the line of symmetry is going to be in the form of x equals to whatever the x value of the vertex is. Once again, the line of symmetry is going to be an equation, and the equation is going to be in the form of x equals to whatever the x value of the vertex is. All right, guys. So that's the basics. Now, how do we graph a quadratic? Let's talk about that. So this is where the h comma k comes in. So there are two forms of the quadratic. We've got the general form, which is in the form of ax squared plus bx plus c. This is called the general form of the quadratic. And then we also have the standard form, or what I like to refer to as the vertex form. And the standard form is in the form of f of x equals to a times x plus h squared plus k. Now, what I am going to be discussing is the general form. I'm going to save the vertex form for another day, okay? Or the standard form, okay? So what I want you to notice is this in the standard form, guys, right here. See, there's your h and there's your k. Once it's in the standard form or the vertex form, you can eyeball the equation and figure out the coordinates of the vertex. And this is where those transformations that we talked about before comes in. So when you have a transformation inside the function, it moves the graph in the opposite direction horizontally, okay? So once again, guys, it moves the graph in the opposite direction horizontally. So be careful with that, okay? And then the number on the outside, of course, is going to what? Move the graph, shift the graph vertically up or down in the same direction. So that's what this has to do with. I am going to just talk about the general form for today, and then we'll save the standard form for another day. All right, so guys, here are the steps to graphing your parabolas. Number one, you want to go ahead and determine if the graph is going to open up or down. And by the way, guys, this is the general form we're talking about. So you got to determine if the parabola opens up or down. Determine the direction of opening. Let me see here. Opens up or down. So which direction is it opening? And I just mentioned that too. If a is greater than 0, it's positive, the graph will open up. If a is less than 0 or it's negative, the graph will open down. Now, number two. The next step is to go ahead and find the y-intercept. Now, this is easy, guys, okay? The y-intercept is where the graph intersects the y-axis. So how do you find it? You let x equal to 0 and solve for y. In other words, plug in 0 for every x, find the value of y. So guys, essentially, if you're looking at the general form, you're finding the y-intercept, you plug in 0 for every x, the problem just simplifies to 0, comma c. So the c is your y-intercept. By the way, I forgot to mention this part. You could also do f of 0. F of 0 will be equivalent to c. That's the same thing, guys, okay? So what we just did was to find one point on the graph of the quadratic. Now, let's move on. Step 3. This is the critical part of the problem, guys, okay, of the graphic. You have to find the vertex. Find the vertex coordinates. And to find the vertex coordinate, okay, we're going to first find x. We're going to use the formula x equals the opposite of b over 2 times a to find your x value. Now, once you find your x value, you're going to substitute to find the y value. So in other words, guys, you find your x value, whatever your x value is, you take that value, plug it into the function for every single x and work it out, and that will give you a y value. So when you work it out, you're going to have your x value, which is negative b over 2a, and then your y value will represent f of negative b over 2a. Ooh, I can see you guys right now. Oh my God, Miss Alcir, that's so confusing. That's okay. I'll explain it further to you once I go to the examples. I can tell when you guys are going to start complaining. Oh, this is too confusing. Okay. All right, guys. So anyways, we use the formula to find the x value, take the value, plug it back into the equation to find the y value. So that will give you the coordinate of the vertex. Now, step 4, we're going to find the line of symmetry. Find the line of symmetry. Write the equation of the line of symmetry, guys. And remember, the line of symmetry shows the same x value with the vertex. So whatever the x value of the vertex is, that's the same value used to write the equation of the line of symmetry. So x will equal to h. Now, once you have all these components, guys, you are going to, here's the process, plot the vertex, plot the y-intercept. Lots of details, guys, especially if you've never done this before. And then you're going to use the line of symmetry to reflect the y-intercept. Then once you've done this, you go ahead and sketch the graph. Sketch the graph. So guys, just like that, you'll have your parabola. So I'm going to do a couple of examples with you, and then we'll be done. Actually, I might just do 3 examples with you guys, okay? So here comes number 1, guys. F of x is equal to x squared, plus 4x plus 1. Make sure I have my squared here. Okay, guys. So first questions first. What's the direction of opening? Which way is this graph going to open? Since x squared is positive, the graph is going to open up. Now, the next part is the y-intercept. Remember the y-intercept, to find it, you plug in 0 for every single x. So if you plug in 0 for every single x, what happens, guys, is that everything cancels out but 1. So there's your y-intercept. Y-intercept at 0, 1. Now, here's the hard part, the vertex. So we're going to find x first. Now, we need to know the a value, we need to know the b value, because we're going to use the formula negative b over 2a. The a value is the number in front of x squared. The b value is the number in front of x. So that's going to be 4. Okay. Great, my battery's low. Okay, so anyways, guys, we're going to get x is equal to the opposite of b, remember that, over 2 times a. So we get negative 4 over 2, which simplifies to negative 2. That's the x value. Now we're going to take the x value, go back into the equation, and plug it in for every single x, and work it out to find the value of y. So negative 2 squared is 4. 4 times negative 2 is negative 8. And then plus 1, we add all this up. So what do we end up with? Negative 3. So that's the coordinate of the vertex. Now, for the line of symmetry or axis of symmetry, remember it shares the same x value with the vertex. So since the x value of the vertex is negative 2, this means that, guys, the line of symmetry will be x equals to negative 2. It shares the same value with the vertex. So now you've got your line of symmetry. Time to go ahead and use all this information and sketch the graph of this parabola. All right, guys. So now we're going to go to the xy plane. First, remember, plot the point of the vertex. And the vertex is at -2, comma, -3, which is right there. Next, we're going to plot the y-intercept, which is at 0, comma 1, right here. Next, we're going to use the line of symmetry. Where's the line of symmetry? At x equals to -2. So right here, straight through the middle of the graph. I'm dotting it out so you can see it. And then we're going to reflect the y-intercept across the line of symmetry so we can plot a third point on the graph. So the point here is the y-intercept, and it's 2 units away from the line of symmetry on the right side. So that's 1, 2 units away from the line of symmetry on the right side. So if you're going to reflect it, you're going to reflect it on the left side of the line of symmetry. So you count 1, 2 units on the left side of the line of symmetry. So now it has been reflected across the line of symmetry. So now you have 3 beautiful points on this graph. So you're ready to go ahead and sketch the graph, and I'm going to go ahead and sketch it out for you guys. And there it is, just like that. We're done, guys. So essentially, you have your y-intercept at 0, 1, and then the reflection ends up at +4, 1. And what do you notice? They both have the same y values, okay? So guys, just be careful with these graphs. Now, additionally, let me throw some questions on here for you guys. They could ask you, does this graph have a max or min value? Since this graph is opening up, the lowest point on the graph occurs at the vertex, so it has a minimum value. And of course, the minimum value has to do with the y value of the vertex. What's the y value of the vertex? -3. Additionally, they could ask for the domain. What's the domain? The domain is all the x's of the relation. Remember, there's no restrictions in the domain, so -infinity to +infinity. And then here's one more, the range. What's the range, guys? What's the lowest y value on this graph? -3. What's the largest y value on this graph? Well, it increases on both ends. So it goes up towards +infinity. Yeah, that was a lot. Okay. So I think I'm going to do one more, and I will stop, especially since my battery is about to go. Let me clear this out. Here's the second example. As always, we'll do some more examples in class, guys. Here's another one. F of x is equal to -x squared plus 4x. And by the way, guys, I'm keeping this very basic. I just want you to be able to graph some basic quadratics. That's it, okay? So on this one right here, let's look. We've got a parabola that is going to open down. How do we know it's going to open down? Because x squared is negative. So it's going to open down. Now, guys, be careful with this one for the y-intercept. If we plug in 0 for every single x, what do we get back out? 0. So the y-intercept for this one is going to be 0, 0. Now, for the vertex, be careful. The a value for this one is -1. Oops, this thing is not writing right here. Okay, maybe not. Okay, and the b value is 4. So when we're finding the x value of the vertex, we're going to do the opposite of b, which is -4, over 2 times the a value, which is -1. So we get -4 divided by -2, which is a +2. That's the x value of the vertex. Now, guys, here's where you need to be super careful, okay? When you plug this back in, because of all those negatives, yeah, be careful. Okay, so that negative is on the outside, so keep it. Square root of 2, you get 4. 4 times 2 is 8. You add, you get +4. There you go, guys. There's your vertex. Now, for the axis of symmetry or line of symmetry, remember this shares the same x value as the vertex. The x value of the vertex is 2, so therefore the line of symmetry is going to also be 2. So now we're ready to go ahead and sketch the graph. Remember, it's opening down. The first thing you're going to plot is the vertex, 2, 4. right here. Next, you want to plot the y-intercept, 0, 0. Now, the line of symmetry goes straight through the middle of the graph, intersects the graph at the vertex. Now, guys, the y-intercept needs to be reflected across the line of symmetry. The y-intercept is on the left side of the line of symmetry. So you're going to go on the right side of the line of symmetry to reflect it. So the y-intercept is 1, 2 units away from the line of symmetry on the left side. So you count 1, 2 units on the right side of the line of symmetry and sketch that point. So guys, we have now 3 beautiful points. We can go ahead and sketch the graph. Ooh, I kind of like missed that point right there, okay? So this is what the graph looks like. Not bad. Okay, so additional questions. Does this one have a max or does it have a min? Since this graph is opening down, there would be a max value. And what would be the max value? The y value at the vertex. What's the y value of the vertex? Positive 4. Next, the domain, we know what it is. So let's talk about the range. Remember, the range is the vertical part of the graph, the lowest y value on the graph up to the largest y value. Since the graph decreases on the left and the right, it decreases down to negative infinity, and it increases steadily until it gets to about y equals to 4. So therefore, your range would go from negative infinity to positive infinity. By the way, if you had to write this as an inequality, it would be y is less than or equal to positive 4 as an inequality. So guys, listen, you've seen this already. This is somewhat of a review. Before, we were doing rough sketching. Now we're doing precise sketching of these quadratic functions, the graphs of the quadratics or the parabolas. So there is another method, the standard form that we use to graph parabolas. But for now, I am going to stop with the general form, and then we'll go ahead and talk about that another time. So for now, guys, we're done. Until next time, bye.